Let's make sure we're ready for the test on transformations. We've been studying this for a while, and hopefully you've got the hang of it. If you need to do this practice test more than once, please do. Please make sure you're asking questions, look at the answers, watch the video several times. Make sure you're ready to do this because we should be able to knock this one out of the park. Okay, let's take a look at question 1 on this practice test. It says, what does the word transformation mean? If we transform something, that means that we change it. So if somebody says transformation, they're just talking about a change. What does the word prime mean? Prime means new. Okay, and what are the 4 transformations that we have learned about? Well, let's see. In order, we learned about translations. Translations. Remember, that's where we slide things around. We don't change the size or the shape or the orientation. We just slide it around. The next one we learned about was a reflection. So reflections. Reflections, and that's where we have a line of symmetry. It's kind of like a fold line where one side would look like the other side of the line, a mirror image of each other. We then learned about rotations, and these guys were all, whoops, let me write rotations a little better. These guys were all rigid transformations, and when we say rigid transformations, what we mean is they stay the same size and shape. They may be oriented differently, but they're still going to be the same size and shape. They're going to be congruent figures still. And then the last one was dilation. Dilations. And dilations, that was where we were stretching and shrinking the shapes, changing the size for sure, probably still similar depending on what numbers we multiply both the x and the y by. If it's the same number, then it would be congruent. Now I'm hoping from the last assignment, last couple assignments, you figured out which one of these you think is the easiest and maybe which one you think is the hardest. I think translations are maybe the easiest, and I think rotations are the most difficult. Okay, this one right here, it's really hard to see, and it's hard to understand how those rules work in rotating those. Maybe the rotation about the origin isn't too hard to see, and the rule isn't too bad for that one, but I think all the other ones, they're kind of tough. So translations pretty easy, reflections not too bad, dilations still pretty good because we've just got that scale factor, but rotations tend to give me the most trouble, and maybe you figured out which one gives you the most trouble, so you can focus on that. And then the last one is do you have your cheat sheet? So you are going to be able to use a cheat sheet on the test, and it looks like this. So hopefully you've got your copy of this. This has an example of each one of these, and it has the rules. I will warn you that if you think you don't need to study because everything's on here, if you're not practicing how these rules work and recognizing these transformations just by looking at diagrams and stuff like that, you're going to have trouble. You're not going to be able to pass the test. So you really need to be practicing this as we go through the unit, and you really have to practice the practice test without using this and see if you can get most of it without that. So if you need that, you can refer to it, but please try and do most of it without. So let's go ahead and take a look here. I've tried to save a little bit of time in watching this video so you can just kind of see what the answers are. This is a translation, so we're going to do a translation of 3 units to the right and 4 units up. So what I've done here is I've written down each one of the coordinates. So here's B, here's C, and here's V that make up this figure right here. And then I went through and I showed, well, we're just going to be adding 3 to every X coordinate, and we're going to be adding 4 to every Y coordinate. Now, if you need to do this, please do it. On a translation, though, you might be able to get away with not doing that. So let me show you what I mean. We're going to take every one of these points and we're going to slide it 3 units to the right and then up 4 units. So 3 units to the right and then up 4 units. If you count those off, that would be B prime. V prime would be 4 units to the right, and 3 units to the right and then up 4 units. So that's going to be right here. So this is going to be V prime. And then 3 units to the right, keep messing that up, 3 units to the right and then up 4 units, so that's going to be C prime. Now when we connect those, if this was the test, as long as we can see that this is the original figure and this is our new image, so this is the pre-image and this is the image if we use that vocabulary, notice that they're oriented the same direction, same size and shape and all that sort of stuff. This is a great translation. Now if you needed to, and on some of these, especially for the rotations, it would be a good idea if you wrote them down. I'm going to go ahead and figure out what each one of these is by actually doing the transformation with the numbers, with the coordinates. So right 3 would be add 3 to the x coordinate, up 4 would be add 4 to the y coordinate. So this is going to be 0, 1. Now let's check and see if that's where B prime is. Don't go right or left, go up 1. We're right where we need to be. C prime would be negative 1 plus 3. That would be a 2. And this would be negative 1. So let's see, 2, negative 1. We're in good shape there. And this would be, let's see, negative 2. And this would be negative 1 also. So back 2 and down 1. Looks great. We've got the right points. Now, if you showed this work, that's awesome. If you can do a translation from a description, that's totally okay too. All right, let's take a look at this translation, another one. This one is written in rules, so it says we're going to subtract 5 from every x coordinate. We're going to subtract 2 from every y coordinate. So I've got those down here, and I've even got the answers. Let's just double check and make sure that we got this right. So this would be 4 minus 5, negative 1. 2 minus 2 is 0. 1 minus 5 is negative 4. Negative 3 minus 2 is negative 5. J was 0, 0, and we're going to subtract 5, so we get negative 5, subtract 2, so we get negative 2. Now, let's go ahead and graph this over on the coordinate plane here. So L prime is negative 1, 0. So negative 1, 0, so we're right here. So that's going to be L prime. H prime is negative 4, 5. So negative 4, negative 5. So we're going to be right here. So there's H prime. And then J prime is negative 5, negative 2. So back 5 and down 2. So we're going to be right here. So that's J prime. So let's draw that figure right there. Does it look exactly the same? Is it congruent? Is it oriented the same direction like it should be if we just did a translation, if we just slid it around? Looks awesome. Again, if you can do this without writing down the points, that's totally okay. But notice that L, we would go, let's see, back 5, 1, 2, 3, 4, 5, and then down 2, 1, 2. So it's in the right spot, so we're in great shape. Now this rotation over here, I'm going to make this a little bit bigger. This rotation here, rotating about the origin. So let's remember how we rotate about the origin. If you can rotate this about the origin, without writing down these points, that's pretty darn amazing. I'm going to go over here and grab that rotation about the origin. You'll remember that on this one, the x and y don't change other than they just change signs. So we don't switch places or anything like that. We just change the sign of each one of these. So if we're going to rotate it 180 degrees about the origin, that's what we've got right here. We're going to take every x coordinate, change the sign, every y coordinate, change the sign. That's all that we need to do. So I'm going to write x, y, and then we're going to change it to negative x comma negative y. Now I'm going to come down here. I think I got most of these written down. I didn't write down k. K happens to be at negative 4, 0. So negative 4, 0. And then we're going to change each one of these. Again, all we need to do is just multiply each one of the coordinates by a negative. So this is still going to be 0, and that's going to be a negative 1. This was negative 2, so it's going to be positive 2, and that's going to be a 4. Those were both negatives, so they're both going to change signs, so that's going to be 4, 1. And this was a negative 4, it's going to be a positive 4, and you can't change the sign of a 0, so that's just going to be 4, 0. So we've got all our prime points. Let's go ahead and graph those prime points and see if we can tell that this is a rotation about the origin. So H prime is going to be 0, negative 1. So 0, don't go right or left, just go down 1. Notice that that's in exactly the opposite direction. So there's H prime. Let's do Q prime, 2, 4. So over 2 and up 4, so that's going to be right here. So here's Q prime. Notice we could kind of draw a line straight through here, right through the origin, exactly the opposite direction. Let's take a look at P prime, 4, 1, over 4 and up 1, so there's P prime. And then the last one is K prime. K prime is 4, 0. So over 4, don't go up or down, and that's going to be K prime. So let's go ahead and connect these and see what we've got. So there is our figure. Now we didn't run into many four-sided figures, but you can kind of tell Q is pointed down here. It's now pointed up there. So it's kind of like we rotated around this way. K was over here, now it's straight over there, so it's like we rotated that one over there, rotated that one up there, and then whoops, and then the H just rotated that around. Again, ugliness in my drawing right there, but hopefully you can see that that is a rotation. We kind of just spun it around there. And I can't do this on the screen, but you can do it on your paper. If you were to put your pencil right on the origin, if you turned your paper upside down, just rotate it on your desk 180 degrees, the diagram would look exactly the same. So we've got that one done. Let's come down here and take a look. I have a a few more of these partly finished off. You'll notice this one says it's a rotation, but it doesn't describe what it is. So on this one, we're definitely going to use our rule here. We're going to switch the X and Y. So switch the X and Y, and we're going to change the Y. So the notation for this looked like this. So the X gets transferred over here. We don't multiply it by anything. And the Y gets transferred over here. It becomes the new X coordinate, but we multiply it by a -1. So let's check and make sure that I did this right. The 2 comes over here, and -2 times -1 is 2. So we're in good shape. We got that one. Again, we're going to multiply by -1 going this direction. We don't change that one at all. So the 3 comes down here. Negative times a negative is a positive. We're in great shape there. And then the last one, we're going to bring the 2 over here. We're going to multiply by -1. So we're going to end up with a 2 here, and we end up with a 4 there. So let's go ahead and graph this and see what type of rotation we end up with. So let's see. There are our prime points right here. So I'm going to switch back to the red. So P prime is going to be 2, 2. So over 2 and up 2. So there's P prime. P prime. And then let's see, Y prime is 4, 3. So over 4 and up 3. That would be right here. There's Y prime. And D prime is over 4 and up 2. So there's D prime. So there is the new figure. That is a rotation of 90 degrees. So take a look at the Y. Y comes up here, D comes up here, P comes up there. And again, if you had any trouble with that, we're kind of rotating in this direction, and there's our 90-degree angle. So this is a 90-degree counterclockwise rotation. We rotated it counterclockwise 90 degrees around the origin. Okay, let's take a look at the next one. This is a reflection across the y-axis. I've got the points over here, but we're going to ignore those for just a second. If we're reflecting this across the y-axis, I'm going to draw that line of symmetry right here. Okay, there's the y-axis. And we go straight across that line. So let's count how far away we are. We're 1 unit to the right, so we're going to put it 1 unit to the left for the new one. We're 1 unit to the left, so we're going to put it 1 unit to the right for the new one. And let's see, 1, 2, 3, 4. We're 4 units to the right, so we're going to go 1, 2, 3, 4 units to the left for the new one. So it looks like this. That's the new one. Now they overlap just a little bit, but you can kind of see a mirror image right along this line. If we were to fold this, the left would lie right on top of the right. Now, the rule for this, let's look at reflection. So we'll grab our cheat sheet just to kind of see. Reflect across the y-axis. The x-coordinate is the only thing that changes. It changes sign. So let's take a look at what happened here. P was 1, 3. So there's 1, 3. It changed to -1, 3. Back 1 and up 3 instead of over or right 1 and up 3. This was -4, -1. So it became -4. Change the sign here and still -1. So there's our n. Instead of going right 4 and down 1, we go left 4 and down 1. So we're just switching right for left. And then this is a reflection right here. It doesn't give the rule, or sorry, it doesn't give the description for it, but it does give the rule. The x is exactly the same, but the y changes. So again, we've got these points right here, and we're going to leave the x exactly the same, and we're just going to change the y coordinate. If it used to be positive, it's going to be negative when we multiply by negative. If it used to be negative, we're going to multiply it by negative, and it will become positive. So the 1 stays the same, the 0 stays the same on that one. The x stays the same, so that stays a 2. It used to be -1, now it's +1. The 3 stays the same, used to be -3, now it's +3. The -1 stays the same, it used to be -4, now it's +4. So if we go ahead and, let's see, graph this, so this is going to be 1, 0 for k prime. So over 1 and up 0. Well, that didn't change at all. That's interesting. Q prime is 2, 1, so over 2 and up 1, so there's Q prime. H prime is 3, 3, over 3 and up 3, so over 3 and up 3 would look like this. So there's H prime. And then M prime is -1, 4, so -1 and then up 4, so we'd be right here. So there is M prime. So we go here, here, whoops, here, and then there. So crappy drawing here. Let me straighten that out just a little bit. Okay, and you can kind of tell, you'd have to tilt your head to line up with the x-axis, but this is the line of symmetry. There's the line that we'd reflect across. So you can tell that the top looks just like the bottom, and that should make sense because the y is the only thing that changed. So instead of going left and down, we'd go left and up to get to m prime, and that explains why k didn't move at all, because it was right on the line of symmetry. Okay, let's slide down here. We got a couple more on this page. These are dilations, and what I've done, or sorry, a couple of them are dilations, and then we've got a reflection right there. What I've done here is I've written down the points, and then we're going to fill in what the new points are. So n is 4, 4, and n prime we get by multiplying by 0.5. If you want to use your calculator, go right ahead. We're basically doing 1/2 times each one of these. So we should know what we're looking for. This is going to take every coordinate and make it half the size of what it used to be. So this is going to shrink this down quite a bit because we're multiplying by a number that's less than 1. So half of this is 2. Half of that's also 2. Half of that is 1. Half of that, I'm going to put 0.5 here because it does have decimals in it. Half of 2 is 1, and half of 4 is 2. So let's go ahead and graph these guys that have primes on them, and let's see what we get. So 2, 2 over here and up here, that is n prime. So there's n prime. F prime is 1 and then 0.5, so over 1 and up a half, so this is going to be F prime. And then I prime is 1, 2, so over 1 and up 2, there's I prime. Now this is, whoops, this is tiny. In fact, I might have to blow this up to get a decent picture and draw this. So let me blow that up just a tad, and here's what we've got. So you can tell that this is a lot smaller. All of the coordinates have been shrunk by a half. This used to be 4 units up, now it's only 2. It used to be 2 units over, now it's only 1. So that one looks pretty good. Smaller, just like we would expect. Now the next one has a scale factor of 2. So if you wanted to write down the rule, here's what's going to happen. XY is going to get changed to, we're going to multiply every coordinate by 2. So you should know what that's going to do. It's going to make this twice as big. So we're going to double this. That's going to be a 4. Double that, that's going to be a 2. Double this, it's going to be a 4. Double that, it's going to be a -2. Again, we're not changing signs or anything here. Double this, we still get 0. Double that, we get -2. So let's check and see what we've got. Here are all the prime notation. These are the new numbers. So this is going to be 4, 2 over 4 and up 2. So there is T prime. S prime is, let's see, 4, -2. So 4, whoops, back 4 and down 2. So that's right here. So this is going to be S prime. And then D prime is going to be 0, -2. So don't go right or left, just go down 2. So there's D prime. So let's connect those. And notice that it does make a triangle. It's similar in size, or sorry, similar in shape. The angles are the same and all that sort of stuff, but it's just bigger. We've scaled everything up by a factor of 2. Okay, last one on this page. We've got a reflection across the line y equals x. Now, if you remember how to do this with the numbers, or you look at your cheat sheet, totally okay to use those coordinates. If you think you can do it by drawing a line, that would be awesome. So I'm going to go ahead and do this, and then we're going to make sure that it matches up with what our cheat sheet would say it should be. So here's what's going to happen. Because this is a diagonal line, we're going to have to count diagonal boxes as we go straight across that line of symmetry so we can reflect over there. So we're going to count 1 diagonal box, 2 diagonal box. So we're going to go 1 diagonal box, 2 diagonal box. That is going to be P prime. Okay? This is Y prime. So let's count diagonal boxes. So let's count really carefully. 1, 2, 3, and a half. So there's a half. There's 1, 2, and 3. So we're going to go right there. So that's going to be our Y prime. And then we're going to do the D. So this is going to be 1 diagonal box, 2 diagonal box, 3 diagonal box. So we're going to go 1, 2, 3. So we're going to go right here. This is D prime. So if we connect those and we tilt our head at a 45-degree angle, tilt it to the right, these should look like mirror images of each other. And to me they do. They look pretty good. Now if you remember what the rule is for reflecting across the line y equals x, great. If you don't, take a look at your cheat sheet and let's see. Reflection across the line y equals x. It says we take the xy pair and make it a yx pair. In other words, we switch the x and y. So let's come back here. Switch the x and y. So -2, 2. So we're going like this, just changing places, not multiplying by anything. So we're going to bring the -4 here, the 3 over here. We're going to bring the -4 here and the 2 over there. Now let's check a couple of these. Let's check D prime. D prime should be at negative 4, 2. So we should go back 4, 1, 2, 3, 4, and up 2. There we go. Let's check this one. P prime should be at negative 2, 2. Back 2 and up 2. So we're in great shape. We've got that all set, all taken care of on the front side. Let's flip over to the back side. So the great thing about the back side is it says give a verbal description and a function for the transformation. They've already got the graph done for us. We don't have to actually graph anything. We don't have to change any coordinates. We just need to figure out what happened here. So let's take a look. And again, it wouldn't be a bad idea to write this is the old one and this is the new one, so we make sure that we get the direction right. So notice that this is oriented in the same direction. X is up here, Q is over here, H is there, X prime, Q prime, H prime. So this is oriented the same direction. This is just a translation. So we're going to write translation, and then we just need to give the directions. So to get from X to X prime, you're going to go to the right 2 units. Remember, we've got to break this down into horizontal and vertical. We're going to go to the right 2 units, and then we're going to go down 1, 2, 3, 4 units. So we're just going to say right 2 and down 4. And then we want to remember how we can write a mapping, a function for that, and it would look like this. Remember, we always start out with x, y, so whatever the original one is, then we're going to say how we change that. Well, to go right 2, we're going to take the old x coordinate and we're going to add 2, and to go down 4, we're going to take the old y coordinate and we're going to subtract 4. That's it. You're done with it, okay? So this is about being able to recognize it and then describe it and write down a rule for it, write down that function for it. So let's take a look at number 12. So this is number 12, and these get a little crazy here. So you'll notice this kind of looks similar to the translation over here, but if you look really close, there's no way it is, because look how long this is, and that's BK over here, and that's a little bit shorter, and that's SJ. So that's not what happened. So what happened is B came over here, K went up there, J went over there, and S went over there. What's happened here is this is a rotation. Notice how I go straight through the origin, straight through the origin, straight through the origin, and straight through the origin to get to each one of those. This is a rotation of 180 degrees. Okay, 180 degree rotation, 180 degree rotation. So however you need to draw that or think about it so you get it, this is rotation, and we'll write 180 degrees about the origin. Okay, and then the function for that, once you recognize it, if you remember what it is, that's awesome. I'd love it if you had some of these memorized. If you don't remember, gosh, let's see. What happens here is the x and the y both change signs. I think they don't change places, they just change signs. So we're going to rotate 180 degrees. So look at that. xy becomes negative x, negative y. So that's what we're going to write down here. Becomes negative x, negative y. There's our rule. So again, the back is pretty easy. Less graphing and more just kind of thinking through what's going on here. So let's take a look at this one. We've got K, it goes to K prime, B goes to B prime, G to G prime. With reflections, it's not as important that you recognize, you know, the old and the new and stuff like that, but I'm going to go ahead and draw these dotted lines, or just some lines right here. And notice we're reflecting across a line of symmetry, and the line of symmetry's got to be right in between these lines, and it's got to be perpendicular. So that is this line right here. That's going to be a reflection across the x-axis. Okay, so the description is reflect across x-axis. Reflect across the x-axis. So we've got the description, and now can remember what the rule is. The rule is always going to start off with x comma y, so we got to be able to get that. And maybe you can think your way through here. Notice to get to k we go back and down, but to get to k prime we go back and up. Same distance in the x direction, but instead of going down we go up, and that should make sense because remember we're flipping vertically here. So here's what it's going to be. The x is going to stay exactly the same and the y is going to change sign. Now we think it's a reflection across the x-axis. Let's flip over here and see if we're right about that. Reflect across the x-axis. The x stays the same and the y is the one that changed signs. So we're in good shape on that one. Okay, last one. And this one, let's see, did they pick any nice points for us? They did. We've actually got a couple to choose from. So this is the old one and this is the new one, and that is very important here when we're doing a dilation, which is what this is. We can tell that it got bigger. So this is a dilation. dilation. And we're going to write that the scale factor is, you got to remember how to get the scale factor. The scale factor, remember, is going to be the new over the old. We find two coordinates that are easy to work with, and we grab those points. So h prime wouldn't be a good choice because the new one would be a fraction. It's in between the two of those. But we could use k and k prime because those are nice integers, or we could use z and z prime. So this one is 0 and up 1, 2, 3, 4, 5. So this is 0, comma 5. Whoops, 0, comma 5. And then the other one is 0, comma 2. So 0, comma 2. And we do the new over the old. Now we couldn't do the zeros because they don't change at all. But the new one is going to be, the new one is 5. The old one is 2. So this is going to be a scale factor of 5/2. And then the function, again, always starts out with xy. And then all we do on this one is we multiply each one of the coordinates by that scale factor. So this is 5/2 x, comma 5/2 y, and we're all set to go there. Okay, let's slide down here and take a look at this last one on the practice test. This is number 15. It says the vertices of triangle ABC are 5, 1, -2, 6, and 3, 0. It says graph ABC and then graph the image after performing a 90-degree counterclockwise rotation and then a translation down 5 and right 1. So this is a composition of functions. We have to do 2 of these. So here's what I'm going to do to make this clear. I'm going to do this one in red. I'm going to switch to blue to do the counterclockwise rotation, and then I'm going to switch to green for the final translation. So that's the way we'll keep these straight, along with using the proper notation. So let's take a look here. 5, 1 for A. So over 5 and up 1. Okay, so there's A. And then B is at -2, 6. So B is -2 and 6. Let's see here. So that would be 6 right here. So that's B. Whoops, make that look like a B. And then C is at 3, 0. So here's B and then 3 zeros. So 3, 0 is right there. So that's C. So I'll go ahead and draw that. Try and make that look nice. Okay, so there's our figure. There's our triangle. We've got the vertices ABC, and then we're going to graph this after we perform a rotation counterclockwise, a 90-degree counterclockwise rotation. So let's think about what happens there. I'm going to change colors. Rotations are tough, so here's what we need to do. Let's go back to our cheat sheet and make sure we've got this rotation right. Counterclockwise. We switch the x and the y changes sign. So let's come over here. Here's what we're going to do. We need to switch the x and y. In fact, I'm going to write down this transformation. So if we want to rotate counterclockwise, we switch the x and y, and we multiply the y by a negative. So we're going to switch the x and y, and we're going to multiply the y by a negative. So I'm going to put a -1 here. So this is going to be A prime. This is going to be -1. And this is going to be 5. We're going to switch, and we're going to multiply by a negative here. So B prime is going to be -6, -2. And the last one, again, we multiply by a negative here, and we switch right here. So let me make that look just a tad better. And so C prime is going to be, let's see, this is still going to be 0. And that is going to be 3. Okay, so let's check and see what we get here. So we get A prime is -1, 5. So back 1 and up 5. So we'd be right here. Okay, so that is A prime. Oops, make that so you can see it. B prime is -6, -2. So this is going to be back 6 and down 2. So we're right here. So this is B prime. And then C prime is, let's see, 0, 3. So don't go right or left, just go up 3. So we're right there. So there's C prime. So this is what it looks like after the first transformation. So we can kind of see that we've rotated here. So we rotated 90 degrees here. We've got that nice 90-degree angle right here. We rotated, let's see, A is right there, yep. So we used to be over here, now we're up there. That's about 90 degrees. Looks pretty good. And we were pointed up here, and then we've rotated 90 degrees down here. So this looks great. Now all we need to do to get the final answer, and if you want to use the points, you're welcome to, all we need to do is move this down 5 and right 1. So we're going to take all of these points and move them down 5 and right 1. So we're going to go down 5 and right 1. So we're going to end up right here. Okay, so there is A double prime. We're going to go down 5. 1, 2, 3, 4, 5, and right 1. So this is going to be C double prime. And we're going to go down 5. So 1, 2, 3, 4, 5 is going to be down here off the charts just a little bit, and then whoops, and right 1. So we end up right there. So I'm going to draw this, and you'll notice that we can kind of tell that this green figure looks just like that original one. It's just that we've rotated it, so it's oriented a little bit different, but it's still a congruent figure. Okay. Again, practice this if you need to, ask questions, and good luck on the test.